Okay, in this lesson we're going to take a look at polynomials which are made up of exponential expressions, and we're going to apply different operations. We're going to add, subtract, and multiply, and then just briefly talk about dividing polynomials. But to get started, we have to talk about what the heck is a polynomial. So a polynomial is a sum, or is a combination of sums and differences of terms. So we're going to start out looking at terms, and we're going to recognize that there's different numbers of terms in different polynomials. So the bottom, we've got a couple examples here of different polynomials. This first one is a monomial. Actually, both of these are monomials because they're made up of single terms. So these two would be called monomials. You just might see that term here and there. And the mono just means that there's one term. Whereas here, 9w plus 5, that has two different terms. They're separated, these two terms are separated by that plus sign in there. That's one way that you can recognize that you've got a binomial or a two-term polynomial. Okay, here we've got three different terms. That is very often identified as a trinomial. And we will do an awful lot of work with these three, monomials, binomials, and trinomials. And I'm just pointing that out so that you recognize that we have different terms here. And this last one is, there's four different terms here. We don't really specify names for that. We just call it a polynomial here. But all of them are polynomials. These are just specific types of polynomials. So polynomials are, sums and differences of different terms. Okay, now we're going to talk about like terms. And we've talked about this before, and we've collected like terms before. But now we want to take a little closer look because that like term applies to the exponent makeup as well. So we're going to look at something like 3x squared and negative 5x squared are like terms because they have the same variable as well as the exponent makeup. And we could actually collect them if we wanted to by collecting these coefficients out front. Okay, here I've got negative 2m squared n cubed, and I've got 7m squared and n cubed. These are also like terms because they have the exact same variables with the exact same exponents. And if we wanted to, we could collect those as well. But this next one, we've got 3x squared y, and we've got 8xy squared. These are not going to be like terms. And if we look at the exponent makeup, they've got the same variables, but the exponents are different. So here, this first one, the x is squared, and the y is not. But in our second term here, the x is not squared, but the y is. These are not like terms because they do not have the exact same exponent makeup. We could not collect those exponents out front. Okay, so we need to recognize where we've got like terms and when we do not have like terms so that we can accurately add and subtract different polynomials. So again, that coefficient is that whole number out front. So there, 3 and 8 are those coefficients there. And it's the number factor of the term. Okay, we can collect like terms, and then we usually arrange those in descending order of the powers. I'm not going to press that a whole lot, as well as I'm not going to press the whole idea of the highest power within a polynomial is the degree of the polynomial. I said it, we covered it, and we're going to move on. Okay, so really our focus here is looking at adding polynomials where we collect like terms. Actually, I'm going to change this one a little bit just to kind of point something out. But other than that, we're just going to go to town here and start collecting like terms. And really what that is looking to identify where do we have like exponent and variable makeup. Both of these terms have x squared, so we can collect these coefficients out front and simplify that to 8x squared. Whereas when I move on to this next one, I've got all different exponent makeup. I've got the same variables, but I can't add all these exponents up or collect all these, I can't add up all these coefficients because some of them have the same variable exponents, some of them don't. So these first two are both cubed. I could collect those. The second two, are just to the first power, so I could collect those. So I'm going to do that by carrying out a subtraction or collecting my coefficients out front. 4 minus 2 is going to give me 2x cubed. And here when I look at these coefficients, I can go ahead and collect those and come up with 7x. Now I'm not adding the exponents. Now if I would add the exponents if I was multiplying these together, but I'm not. Okay, and this next one, the 24 can collect with a negative 24, and our cubes can collect here. So we can see that the 24s are going to cancel each other out. And then when we take minus 4 cubed, 4x cubed, with adding 4x cubed, we'd end up with negative 3x cubed. So we're just collecting that coefficient out front. And there's an implied 1 there. Okay, here I can go ahead and collect my first two terms because they're both the same exponent to the same power. So I can collect them. That's like an implied 1 there. So 5 minus 1 would give me 4x cubed plus 4. Now here I'm going to go ahead and circle my to the 5th power. Notice I'm capturing that sign out front because that's part of that coefficient term. And then I'm going to underline my other two. So I'm just coding my work so my eyes are catching the right one. So 2x to the 5th power collected with negative 3x to the 5th power, I'm going to have negative x to the 5th power. And that's like a negative 1 there. I can write it or not. And then I'm going to collect the coefficients for our squared terms. So I would have 4 minus 2 would give me 2x squared. Now what I wanted you to see here, and the reason I threw the parentheses on this one is I just want you to see that sometimes you'll have two different polynomials that you're going to be asked to add together. Well, whether the parentheses are there or not, it's still a matter of just collecting like terms. So we're going to do 7x cubed collects with this x cubed here, and again that's like an implied 1. So we've got 8x cubed. And then there's nothing to collect the minus 3x with, so we just bring that down. There's nothing to collect our negative 1 with, so we bring that down. Okay, so at this point we've practiced collecting like terms or adding polynomials, which are, adding polynomials is just collecting like terms of all the different terms within the polynomials. But subtracting polynomials, you've got to be careful. Okay, so what you're going to do is you're going to add the opposite or the additive inverse of the polynomial being subtracted. Like, what the heck does that mean? That means you're going to look and you're going to subtract each term in the whatever you're subtracting. So in this, I'm going to slide this up here so we can see all of these. So in each of these situations, we've got a polynomial and we're subtracting another one from it. So we're subtracting a whole series of things, terms. Okay, so in this first one, what I want you to think about is, I think it's easiest to think of taking a negative 1 and distributing a negative 1 because you're going to take the opposite sign. And I kind of drew these little rainbow effect here, implying that I'm multiplying each term by negative 1. Anytime I multiply by negative 1, I'm changing the sign of each term. So that would mean instead of collecting 5x cubed, I'm going to subtract 5x cubed. And then when I say a negative 1 times a negative 4, in other words, the opposite sign here would be adding 4x squared. The opposite sign here would be subtracting 2x. And the opposite sign here would be adding 1. So what I need to think about is when I'm subtracting everything in that second set of parentheses, I'm collecting its opposite sign. So I found another way to write all that. A lot of times you can just scribble that out. And then you've kind of created a situation where all you have to do is think about collecting like terms. So here I'm looking for matching up both of my cubic terms and then looking at the coefficients. So 7 minus 5 gives me 2x cubed. And this next one, I've got 8x squared collected with 4x squared is going to be 12x squared. Okay, and this next one, negative 2x collected with negative 2x is minus 4x. And then the 4 collected with the 1 is going to give me plus 5. So I had one added step in this problem, which was changing the signs of that whole polynomial, changing the signs of each of those terms so that I'm subtracting each of those terms from its partner in the first polynomial. Once I've done that, it's just a matter of collecting like terms. Once I've distributed the negative 1. So I'm going to distribute a negative here, in other words, changing each of the signs. So I'm actually going to subtract 3x and subtract 5. I found a new way to write that. So collecting 7x with negative 3x is going to give me 4x and then minus 5. Same thing here. I'm going to change all these signs. So I'm going to have minus x squared. That becomes plus 5x. This becomes minus 7. So I found a new way to write all that. So 4x squared collected with negative 1x squared is going to give me 3x squared. 2x and 5x is going to give me 7x, and negative 5 and negative 7 is going to give me negative 12. This next one, I'm going to be subtracting x squared. I'm going to be adding 8x. Okay, so I found another way to write that. So I'm going to have 4x squared, 4x squared minus 1x squared is going to give me 3x squared. And then 3x with 8x is going to give me plus 11x. Okay, I'm going to move on, and we're going to try our hand at multiplying and seeing how this is different. So I want you to, when we're looking at this is just communicating that we're just multiplying two different, in each of these cases we have two different monomials. So we're going to multiply the whole numbers out front, the coefficients are on the baseline. We can actually carry out that multiplication. 3 times negative 5 is negative 15. And x times x, that's x to the first power, x to the first power is going to be x squared. So you're going to see that you are combining your math skills here. You are multiplying whole numbers, just your regular multiplication, and then you're combining your exponent rules for multiplication. So you're putting all that together. This is like a negative 1 in front of here times a negative 1, which would be positive 1, and then x times x would be xy. So that just simplified to be, and again, two negatives, there's your pair of negatives, your answer is going to be positive. Here I've got a negative times a positive, so that's going to be negative. And then x cubed, or squared, times x cubed is going to be x to the 5th power. And here we've got numbers on the baseline. We can actually carry out just regular multiplication. 3 times 4 is 12. I can carry that out because those are both base numbers, are on the baseline. But here I've got x to the 5th power times x to the 2nd power. I have to apply my exponent rules so that when I'm multiplying like bases, I add those exponents. So that's going to be x to the 7th. Here I've got numbers on the baseline again. So I can carry out that multiplication. 4 times a negative 2 is negative 8. And then when I go to my variables, I've got a variable y to the 5th power times y to the 6th power. I'm going to use those exponent rules. So that would be y to the 11th power. And usually this is where students kind of hit the brakes a little bit, because you've got to really think both your regular multiplication with the numbers on the baseline, those coefficients, as well as pull in your exponent rules. Okay, I'm going to pause there because this is getting a little long.